Hi, I'm Rick Kitamura and a master student at Keio University in Japan. I will give a presentation ambient display utilizing anisotropy of tatami. This time we use tatami, a traditional Japanese flooring material, to create both a static display and a dynamic display as shown in the video. First, background. In recent years, digital signage has become a popular display method, but ambient displays blend more naturally into the environment. Ambient displays, as shown in the figure, use physical materials instead of screens, integrating information seamlessly into real-world objects. This display makes information feel more natural and approachable in various environments. The figures show examples of dynamic ambient displays that use bubbles, ions, glass, and magnetic pins. Unlike traditional displays, these can change their patterns dynamically and allow precise control at the pixel level. The figure shows a display that utilizes anisotropy. Anisotropy is a property when an object characteristics change depending on direction. For example, the appearance of a carpet changes depending on the direction you stroke it. Additionally, the brightness of a wood blocks changes depending on the viewing angle. In this way, anisotropy affects color perception, allowing different expressions by changing the viewpoint or light source position. Based on this, we created an ambient display using tatami as a physical material. Since tatami also has anisotropic properties, so we use this feature. We propose two displays for presenting information, static display and a dynamic display. These displays allow information and art to blend naturally into Japanese gardens and temples, offering a new way of presenting information within Japanese culture. For about 1,300 years, tatami has been used as a flooring material in traditional Japanese architecture. In modern times, the design and materials of tatami have become more diverse. However, with the increase in Western-style rooms, the production of tatami has been declining year by year. So therefore, this research also aims to discover new value in tatami. Tatami is made up of three main components. The surface of tatami is mainly made of lash, igusa, or wash paper. Lash is popular for its natural scent and texture. Wash is coated on the surface, making it resistant to color changes and dirt. In the works discussed later, tatami made from lash is used for static displays, while tatami made from wash paper is used for dynamic displays. Tatami changes color due to its unique surface structure. Woven lash creates a directional pattern, so making the surface look like line-up cylinders, as shown in the left figure. So when rotated, the light exposure areas shift, altering its appearance. As shown in the video, 19-degree rotation changes the illuminated parts, making the color look different. And we quantitatively evaluated color changes, but will omit the detail due to time constraint. As a result, rotating the tatami changes its brightness, altering its appearance. Based on these findings, we developed both a static display and a dynamic display using tatami. First, I will explain the static display, which is a work by my CEO author Kenji Yamada. Today, I will introduce his work on his behalf. The production process begins by analyzing the lighting conditions of the exhibition space, as the amount and direction of light vary. Next, the design is sketched and the template is adjusted to fit the display area. The tatami base is then cut to match the template. The surface of the tatami is also cut and folded accordingly before being attached to the base. Finally, the completed tatami is installed in the exhibition space. Here are some examples of the artworks. The crane design consists of 301 pieces and took a year to complete. The dragon design required 6 months to create. The hexagonal design resembles the expression used in the dynamic display. However, producing hexagonal tatami is particularly challenging. These static display works require great craftsmanship and time, resulting in highly expressive artworks. So by adding artistic elements to traditional tatami flooring, we are creating a new added value. Next, I will explain the dynamic display I created. Dynamic display, one circular tatami is used as a single pixel. By arranging these pixels, various images and the animations can be expressed. Circular tatami is the easiest to make, and anyone can create a large number of them. The display consists of 16 tatami pieces arranged into one module, and this time 16 modules were created. Each module is a square with a side length of 26.8 cm and a height of 44 mm. Additionally, the modular design allows the display size to be adjusted based on the installation location, making it highly scalable. This system can represent 256 pixels, so simple images and text can be displayed. And additionally, simple animations such as countdowns or gradation can be created. It takes about 0.1 second to rotate from 0 to 90 degrees. All of these examples use only natural light. In this way, these displays are expected to be used not only for artistic purposes, but also as an information display method that naturally integrate into everyday life. These displays were exhibited for about a month. The static display can be stepped on. Visitors were seen lying down on the tatami and taking photos, showing that the display blended seamlessly into the space. It was highly praised for maintaining the functionality of tatami while also having artistic value. The dynamic display is small in scale, but the fusion of technology and traditional Japanese culture was particularly appreciated. Finally, I will discuss the future work. Static displays are difficult to produce, so a design tool is needed to simplify the process. In this case, our quantitative evaluation of tatami's color changes will be useful. Dynamic displays cannot be stepped on, so we are exploring interactive features, like moving tatami when users hover their hands over it. And this time we use natural light. Artificial lighting can highlight specific areas as shown in the figure. So we are exploring this and other aspects like color expression, user studies, and use cases. This is a summary of my presentation. Thank you for listening.